Well, welcome back. This is our Algebra 2 sequence and series, lesson number 5, geometry series, homework review, part 4. Again, please make sure you catch parts 1, 2, and 3. Part 3 ended a little bit abruptly, ran out of time. Hopefully you caught those. They were really starting to get a little more tricky. Making sure you definitely have your calculators set up, and just knowing in this case doing fractions, right? Basically, if you round off, you'll find the answers not working out so well. So you really have to have a good understanding of fractions in some of these things. Okay, so for question number 7. In the picture shown at the right bottom, the outermost square has an area of 16 square inches. All the other squares constructed by connecting the midpoints of the sides of the square is inscribed in. Now, inscribed is written inside. Find the sum of the areas of all the squares shown. First, consider how the area of each square relates to the larger square that surrounds or circumscribes it. Now, the interesting part in this case is that if we were to take this triangle here, all right, and fold it over. So let me just see if I can just do this here. If I maybe clone this here, or clone this picture, clone. All right, and so then I'm going to maybe rotate it. We would see that it fits to be basically a quarter of the square. All right. And so why does that matter? You'll see here in this case, if I repeat this process, okay, that this triangle is really 1/8 of the entire square, large square. Now, why is that? Because each of these pairs of triangles here will form a quarter of the original large square. Okay, so saying, all right, that's okay. What's the big deal? Well, now let's consider this. What if I were to now clone this triangle, right? Same triangle, okay, same with the same exact shape and area. Oops. Trying to be able to show it to you. I'll turn this around. Okay, we can do it this way. All right, maybe we do. Oh, here we go. All right. Oh, you know what? I gotta flip it. I'll flip it here. Sorry about that. Flip this here. Okay. And I think in this case, can I fit this in here? I just want to be able to fit it in to the other square part. Oh, I know. Yeah, sorry about that. Yep, all I can do is this. I'm going to bring this here. All right. So now, why am I showing this to you? Do you notice in this case that each of these triangles, each of these triangles is 1/4 of the next square. So you're saying, well, okay, what's the big deal? Well, if you need 8 of these triangles to form the large square and 4 of the triangles to form the next square, it will mean the area of the next triangle, next smaller triangle is 1/2 the first one. So if the area of the first triangle is 16, then the area of the next triangle is half of 16, which is 8. And we see this pattern continues, all right? So yeah, so it comes down to is that the area of this triangle, of this square here, is going to be half of the area of this large triangle here. And what happens from there is that the next square will be 1/2 the area of the previous square. And we keep following the same pattern here. All right. Then the next one is 1/2 of the original, and so we're constantly getting 1/2 of 1/2 of 1/2. So we could, in this case, since there are going to be, it looks like in this case, how many squares are there? It looks like 1, 2, 3, 4, 5, 6 squares altogether. So we would just do half of each one. We could do, in this case, +4, +2, +1, and then +1/2. Okay? So again, if the area of the largest square is 16, then the area of the smallest square, the sixth square inscribed, 1, 2, 3, 4, 5, 6, would be 1/2. And so we can add these together. All right, this is totally okay. We can add them together. I would group them the following. 16 plus 4 is 20. 8 plus 2 is 10. So I have 31.5 as my sum. And that would be square inches because it's 16 square inches for the first one. Now, this works out fine, but what if the numbers weren't so good? Okay, so let's now consider the following. That we'll use our sum value. So our S of n is equal to a1 times 1 minus r to the nth power over 1 minus r. Well, our a1 is 16. N is equal to 6 because there's 6 squares. And our r value, again, we figured out is we're multiplying by 1/2 to find the next value. We did 8 over 16. R is equal to 8 over 16, which is 1/2. And so we'll plug this into our formula and we'll see if we get the same answer. So is the sum of 6 equal to 16 times 1 minus, and I'll use 0.5 to the 6th power all over 1 minus 0.5. Okay, and if you type in the calculator, this will look like this, 16 parenthesis 1 minus 0.5 to the 6th power. Now you're probably saying, why don't you put parentheses around 0.5? Because I'll need to, that 0.5 is a positive number. I always have to worry about negative numbers, no. Or put parentheses around a fraction. But I can express what the 1/2 is, 0.5 is decimal as an exact value, so that's okay. Divide by parenthesis 1 minus 0.5. So let's type the calculator. So we have 16 times 1 minus 0.5 raised to the 6th power, close parenthesis, oops, wrong, close parenthesis, all right, divide by, open parenthesis, 1 minus 0.5, close parenthesis. All right, and we'll see this is 31.5, and yes, we get that as well too. So just verifying in this case that both methods are fine, but if you want to use the formula here, we would get the same answer, just identifying in this case, inches squared. Identifying in this case the r value, the n value, and the a1 value. I'll make this full page here. Okay. All right, and so this will be the end of our Algebra 2 sequence and series, lesson number 5, geometric series, homework review, part 4. Part 4. All right. Again, if you have a chance, please give it a like if you found this helpful. Ask questions. Ask questions. Like if you weren't sure about something, leave them in the comment section below. And I look forward to seeing you guys in the next video. Make sure to catch the other 3 videos, 1, 2, and 3, and of course, the next videos 5 and 6. Take care, everybody. See you in the next video.